So in this video we will discuss the house price prediction, the actual problem, right? There means this particular problem, there are a lot of data is available that we will use for predict the Boston house price. So in the previous session we discussed some basics about the linear regression part, and now with the same concept we will try to solve the one complex problem. So here on the Toronto Education website some data is given, and in this particular data set there are total 14 attributes, means total you can say the 14 column is present, and on the basis of that here you can see this 13 is the means independent variable, and on the basis of that I just want to predict what is the median value of the owner occupied homes. So now what we need to do, this is the complex problem, and their approx data set size is also approx 500 means row present there. So here we will use some software like Python to solve this particular problem and for making the linear regression model. Okay, so we try to do the thing. So Google Colab, instead of installing the Python we will use the Google Colab. When you open the Google Colab, there you can click on the new notebook, then new notebook will open. Okay. Okay, you can give any name to this notebook. I will write here linear regression. Okay, and then you can write the linear regression model. Okay, so what we need to do in the Python is first we need to import some general libraries which is required. Okay, so we know that for import the Excel file inside the Python we require the pandas, and for visualization we require Matplotlib and Seaborn. Okay, so that all the library which required that I will import, and we can write here import means pandas as a PD. And if you don't want to write all this thing with the help of the generative AI, here you can write import pandas. Okay, Matplotlib and Seaborn. Okay, so now import code means no need to write any code. The generative AI will help you to write down the code. So this code, all the code is now game, and just you need to run the code. Okay. Now the next point, I need to import the Excel file. So first I will import the Excel file from my device. Okay, so here what you need to do, import, just click on the import. Okay, even the data is this data related means link also I will share. So just click on the import and then you can import your data. Okay, so now this is the CSV file I imported inside my system. Now how to read this, just click copy path. Okay, and here you can write pd dot read, or even if you don't write the code, here you can write import file from. Okay, then you can import, no need to write the code. Now means here what is the df means our data, Excel data. It is the variable name, you can change even there sometime df, there maybe you can write the data data is equal to this, means this entire Excel file is now available inside your Python system, right? Now, what will be the next process? So when we want to make means a regression, right? It may be the linear regression or any another regressions that we will discuss in the coming session. So we need to divide the data into the two things. One is the dependent variable and another one is the independent variable. So what I will do, I know actually what is the dependent and what is the independent variable here. The mean median value of the price that actually I want to predict, so that is the y, and remaining all are the x. Okay, so here what I will do, uh, here generate code with df, just click on that and you can write here, consider MEDV is the median what is the name, median value of the house. Okay, median value or median price. Okay, so that actually I want to consider as a y means dependent variable, and other as a x. Let's see what will be out. Now you can see you created x, means that is the all column except MEDV and only MEDV column. Okay, so now this is the x, means now your data in two category. One is one in the form of what, means when I pass just x, you can see what the data you have that is related to dependent variable, and if I pass the y, what the data I have that is related to independent variable. I'm sorry, y is the dependent variable and x is the independent variable. Okay, now it's very easy, no need to write, even I am not written a single line of the code. Everything I am trying to do with the generative AI. So what will be the next, now x, y, as we divided the data into the dependent and independent variables. The next point, I just need to split this x and y into the train and test. So here also you can write split x and y into, or please make train test split for x and y. Done. Okay, so now if you see what is the size of the train, okay, data, so that also you can see. Okay, and even you can see with the help of what, so train tells all the size you can see. Means what I did now, I know that what is the shape of the x dot shape, that I know the shape is 506, and there I am considering the 80% data for what, for training purpose, and 20% data I am considering for the testing purpose. So now means train test split done. What I will do now, I will make the model on what, on train data, right? And then I will test that particular model. So I want to create the linear regression model, right? So you can write make linear regression model. Okay, on training data, right? So you can write x train and y train. So from sklearn library actually required to create the means machine learning model. Okay, means basic machine learning model. So from sklearn.linear model, you can see here import linear regression. Then it will call the model from sklearn, like model is equal to linear regression, so create a linear regression model. And now in this particular linear regression model, means it's called the linear regression here. And now when I pass model.fit and xtrain and ytrain, okay, model.fit means I'm passing the data and this model is created. Okay, now what will be the next point? Now you can check the model also. Okay, so what you can do here, model check accuracy of the model. Okay, so like that you seen means what I did first, I just passed the prompt import pandas matplotlib and seaborn. It will import all the library and then run the code. Then we will just insert the data set here in the Python. So what we need to do, import file from this particular location, then it will import with the help of the pandas library. Then df, you just need to write the df, then you will get the output. Then here also you can see what I'm trying to do, just you can say means consider this MEDV as a means you can say the dependent variable and other as a independent variable. So I need to divide this df into the two form x and y. So what I will do, consider MEDV as a means y, okay, means y means generative AI will understand we are talking about the dependent variable and other as x, okay. So it will make the axis x and y. X is your dependent variable and y is the independent. Actually x is I'm so sorry, independent variable and y is the dependent variable. And then what we will do, we split the data into the train and test, okay. So what I need to write, from sklearn dot model selection import train test split, okay. So that is available inside the sklearn, and then we can split the data, okay. So for that what we need to write, train test split xy, test size is equal to 20% and remaining consider 80% as a means you can say quickly is your training data, and the 20% is the test data. And random state is equal to 42 I'm passing. Everyone should be passed the 42, because if you pass the 42 and I'm also passing the 42, it means what, means the way to divide the data will be the same, okay. If you pass the 10, it means the machine will consider every 10 number like that, the way will be the different, okay. So random state 42 means I'm telling use some specific method and divide the data into 80-20 split, okay. And if you pass the 10, then the way will be the different, okay, but you will get the split of the 80-20. Then x train shape you can check, y train shape means you can see this is the 80% of the actual data set, okay. Now how to make the linear regression? So there means sklearn is available, so you just need to type here make linear regression x train y train, and you will get the linear regression, okay. Now make prediction, or you can say check the score of the model. So it will check the score of the model, and that is the 66%. And even you can check the score, okay, this is the 66, and if I pass uh, 1 minute, x train y train score, okay. So if I pass the test means test data, then accuracy is 68.6%, but when I pass the train data, the accuracy will be obviously high, because the model train on this particular data, so that's why it's give the high accuracy, right? So then we can do the cross validation to check the model actually giving the right result, or it is a by chance, okay. So here you can see from sklearn.model underscore selection import cross val score. So there cross validation we can do with the help of this particular module, okay. No need to remember, just you need to type do the cross validation on the model. So from sklearn.model selection import cross val score, and here you can see the cross val score actually used is the 5-fold cross validation, okay. And you will get the result here, print cross validation score, there I'm passing the score, and the average validation score, there I'm passing the mean. So here you can see, so I'm getting the score, okay, and that is the only 35%. So this actually the 75% and 66% it shows by chance. There the model accuracy always not a 66 or 70%. Sometimes it means give the negative, means this is the worst result, okay. Even here also you can see the result is not appropriate. Okay, so this means model is not that much reliable. We can't use this particular model for some real life prediction. Okay, for the prediction purpose. So now there is the one more thing that we will do: make the lasso model on the X train and Y train. There lasso alpha is equal to 0.1, so that is the hyperparameter for the lasso. And what is the alpha means? I'm considering the means I'm considering their means actually means one penalty. Okay, and that I'm adding, and I will get the 0.1 the lasso model. Okay, so like that we can do the prediction.